So, to a cyclist travelling north at 7 meters per second, the wind appears to blow from the northwest. To a pedestrian walking due west at 1 meter per second, the same wind appears to come from the southwest. Find the magnitude and direction of the true velocity of the wind. Okay. So, what we're looking at here is two scenarios, okay, or two cases. We call this case 1. So case 1, we're always going to set the wind as xi plus yj because we know nothing about it. Okay, so that's the velocity of the wind. Now the second thing is we're going to set the cyclists, velocity of the cyclists is going to be north at 7 meters per second, which is going to be 7j. Okay, and then next one then is going to be the velocity of the wind relative to the cyclist. Remember, it has to be how the wind appears to the cyclist. So VCW doesn't make sense, but VWC makes perfect sense. And what that is, it's VW minus VC. And once we've established that, what we can then say is that VWC is x minus 7, or sorry, xi, excuse me, xi plus y minus 7j. Have you enough of that? Okay, case 2. Once again, I'm just picking up marks at the moment. Case 2, the velocity of the wind stays the same. Stays xi plus yj. Then the velocity of the pedestrian this time is going west at 1, so minus I. And then velocity of the wind relative to the pedestrian is Vw minus Vp. And what you're going to get there is Vwp is going to be xi plus yj minus 1i, and what we're going to get then is going to be velocity of wind relative to pedestrian is going to be x minus 1i plus yj. Now lads, you more or less pick up 10 out of 25 for that.
Or be x plus 1.
What? 2 minus to make a plus, you're right. Sorry, forgot it's minus minus. So that should make it plus 1. Just double check here. Yeah, you're right. X plus 1. Okay, so x plus 1. Thanks for that. Now, here's where the tricky part kicks in. The tricky part is you're going to draw your diagram and you're going to figure out is there anything that needs to be done with this. Okay, thank you. So, what we have here is just going to draw the xy axis. Now, case 1, where's it coming from? It appears to blow from the northwest. So where's that actually going? Southeast. Now, what did we say about the southeast quadrant? We said it yesterday, we summed it up. Which one of the components is negative? What? J. Now, what I always do is I always run over a really simple scenario in my head. I go, if it's going southeast, it's the same thing as 4i minus 4j. And if I want to find out that this angle that we all know is 45 degrees, right? If I tan inverse that, and it should be 45 degrees, okay? So when I tan inverse that, what I'm going to have to do is I'm going to have to fix the j components to make it a positive value. So, in this scenario, tan x would equal, it'd be minus 4 over 4, but the problem with that is it's coming out as negative, so I have to put an extra minus on the j component. So you end up getting tan x equals 1. This is the same thing. Northwest means 45 degrees. Okay? And in this question, instead of having tan inverse 4 over 4, what we're looking at is getting the tan inverse of, what are we looking at here again? It's x across, and y minus 7 down. Problem with this y minus 7 is it's actually a negative number. We just haven't identified it yet as a negative number. So what we're going to do is it's going to be minus bracket y minus 7 all over x, and we know that this angle here, which I previously called x, but it's no longer x, it's 45. So tan 45 is 1. 1 equals minus y plus 7 all over x. Bring the x over to the other side, then bring the y up. So the x cross multiplies up, then bring the y over. You're going to get x plus y equals 7. Happy enough with that? Now, we're on case 2 now. And in case 2, what we're looking at is what direction is it coming from this time. Okay, so in case 2, I'll just do it like that. Alright, so case 2, we're looking at it's coming from the southwest. So, come from the southwest. If it's coming from the southwest, what does that mean? Going northeast. So it's going up this direction here. Now, what's great about the northeast? Everything's positive. So an example of a northeasterly wind would be 4i plus 4j. Both of them being positive means that the angle x is very easy. It's just tan inverse 4 over 4, which means I don't have to do any adjustments, which is excellent, right? So we're just going to apply our own numbers to this time. So our own numbers are going to be, what are our own numbers going to be? It's x plus 1 and y. So, and once again we know it's tan 45. So tan 45 equals x plus 1, or sorry, y over x plus 1. And then we all know that tan 45 equals 1. And we're going to get x plus 1 equals y. And now we're going to get x plus y equals, x minus y equals minus 1. So our second equation is going to be x minus y equals minus 1. We now just got to solve the simultaneous equation. I'm not going to go through that, I'm just going to write down what the answer is, save time. Okay, so when you solve the simultaneous equation, what you're looking at is that x is going to be equal to 3 and y is going to equal 4. Now, if you read the language of the question, we haven't quite answered what we're looking for yet. We're looking for the magnitude, the speed, and we're looking for the direction of the true velocity of the wind. So we haven't quite answered our question yet. We've got the velocity of what's the velocity? It's going to be 3i plus 4j, but that doesn't answer everything we need to know. So what we're looking at next is that's 3 across, 4 up. It's a 3, 4, 5 triangle. When you do Pythagoras' theorem, you'll find out that this is 5. Then it's just a matter of finding out what the angle, we'll call it angle A this time, over using x. So tan A, can somebody need tan inverse 4 over 3 for me? So A equals 53.13 degrees. And so what's our answer then? Direction needs north and south to go with it. Anybody know? What about 53 degrees north of east? Okay, so it's 53.13 degrees. Alright, 53.13 degrees north of east. Okay, so it's north of east. Or what would be another way of writing it? East 53.13 degrees north. Okay, lads.